Welcome to chapter 9.6, Seeing the Light. In this chapter we'll have a look at exactly how light is used in humans and other animals to view its environment, and exactly how we manipulate that light in order to do so. So what we're looking at here is a diagrammatical picture of the eye. We have the eye here, and the pupil, and the cornea, and the iris, but most importantly we have the lens. The lens, and then we have the retina. Now, the goal of the lens is to concentrate the light from distances all onto a single point. Okay, we need it to really hit this retina on a single point so it can be transmitted to the optic nerve. So the rest of what we're really talking about is some of the difficulties with that, and how it goes about making sure it all comes down and hits a single point. So one difficulty that we have is that a biconvex lens, which is a lens that's convex on both sides, it tends to flip the image. So if we have the top, imagine the top is down here, we end up with an area that's basically on the bottom over here, and we get one over there, and we end up with it's up the top over there. So if we imagine a person here, maybe we'll actually draw him in. Alright, whoops, I don't know why he's leaning, but yeah, he's leaning. Alright, I don't know what that thing is. Let's do that. Okay, so what we'd end up with is exactly the opposite over here. So the head would be down there and the arms would be down there. You see how that works? Because the head, the light from the head is going through the lens and sending it upside down, right, over there. So that's what happens when you hit it through a lens. And we actually have to, the brain receives all the images that we see upside down. It has to, computationally, as in, it has to do some calculations to flip all the images up the other way. There's actually cool ways you can trick the eye into kind of making that mistake. But this next picture is kind of cool over here. I'm just going to rub that out so it doesn't get in the way. Let's rub that out. The eraser. Here, and rub that out. Nope, that's not going to work. Oh well. So what we have over here is an eye lens, all right? And what we notice is when the light is far away, the lens thins itself to like more of a thin, streamlined aspect, so that when the angle of refraction comes in, it comes down to a single point. However, when that object comes closer and it's from a nearby object, the lens fattens out so that angle of refraction is closer. So it still hits that same exact point, So, and that flexibility is what a lot of people lose in their old age. So this ability for the lens to fatten out. So you might see that they're fine looking from far away, but when things get a bit closer, they can't really see it. And that's why old people tend to hold newspapers and books at arm's length rather than any closer, because their eyes, their lenses have kind of hardened a bit, and they don't kind of squish in and become fat like they should, or like they do when they're young. Okay. Another thing I want to point out here is the focal point. That's an interesting thing. The focal point is basically where the rays should all converge. All right, let's have a look at the next slide. Okay. So what we're looking at here is an endoscope. Basically, it's a huge cable that they, in this case, have shoved into someone's stomach, and this cable is full of fiber optical fibers that allow light to enter the tube, and then run back up the tube all the way into a computer that will allow it to be seen. That way we can get an inside view into our innards, as it were. Let's have a look at how they. So these are optical fibers. You can see here there are the tubes are here, and you can see the light kind of being emitted from the end. So the light is kind of all the way up the other end, It could be kilometres away, really. But the light can't really escape very well until it gets out the end, and then it's nice and bright. Okay, so let's have a look. This is kind of the innards of an optical fibre. You'll notice there's a plastic jacket to kind of protect it, and it's this glass and in the core that's kind of most important. This light, you can see it can bounce around the walls, but it can't get out. So, in this way, it can travel along these optical fibres for, a very, very long, quite a far distance, and we can communicate, over that distance as well. All right, so this is a nice and short one. What I'd like you to do is go to chapter 9.6, put all the blue words into Quizlet, and I want you to answer questions 1 to 14. Questions 1 to 14 tonight. So if you can answer those, and I will see you next class. Thanks.